And the timing was never certain. So.
Just when we're getting our hybrid approach down pat. It's all good. Good. Everybody joining here, welcome everybody. Yeah, we'll get things kicked off in a minute or so.
Mike?
Yep.
I think it's time for you to start.
Okay, awesome. Well, all right. Good evening, everybody, and welcome to the March edition of the Java or Garden State Java User Group. Very snowy New Jersey, and thanks for adapting your schedule to watch this meeting from home, where you're more comfortable and warm instead of trying to brave the elements out in this messy weather today. So, and also for our guest speaker Cameron Purdy, who's in Boston, I think New England is getting hammered a bit. So this was a great solution to to hold the meeting instead of trying to postpone it. So in any event, I'm going to share my screen. We'll get things going. Okay. Slideshow. Okay, there we go. Okay, so as usual, we always thank our sponsors, who support us throughout the year. We'll talk about what's new. I'll introduce Cameron, and then after his talk at the end, we always talk about what we're planning for the remainder of the year, and also even give a shout out to some of our friends of other Java groups like Philly, New York, Atlanta, Chicago, and Kansas City. So and then we'll have our giveaway, as we do for a license to IntelliJ IDEA. So our platinum sponsor is JFrog, the DevOps company. So give them a look on I think jfrog.com. They're our premier platinum sponsor. And sorry. Our silver sponsor is Azul, makers of Zulu, the downstream distribution of OpenJDK. At least it used to be called Zulu. I'm trying to remember if they know they made some changes, but we are partnered with DevNexus, which, by the way, is going to be held in Atlanta, April 4th through 6th next month. So check that out. I don't know if registrations to attend are still open. But there is an awesome set of speakers. This is a premier conference throughout the year among some of the others. And then we have our per meeting sponsors. JetBrains, of course, they provide a license, for the IntelliJ IDEA, which me personally, I use and pay for my own license, and that's how much I really like it, along with some of their other products too. The folks at Eclipse, they provide hosting on Crowdcast, which we've used in the past, but I'd still like to acknowledge them since that is available to us if should we decide to go back to using that video conferencing. So what's new? I did not update this, to be honest, but but I'm a committer on the Jakarta NoSQL and Jakarta data specs, and they are on track to be part of Jakarta EE11, which is scheduled to be out in the first quarter of next year. So we have been doing a lot of the Jakarta EE specification work in order to make that happen over the last few months. Jakarta NoSQL is version 1, beta 6 is the latest, which is compatible with JDK 17 and Jakarta EE10. So I'm updating my beer database application, which connects to NoSQL, and to update the source code that way. So actually, this is old news here since that's already happened. And Reza Rahman put together a contributing guide to Jakarta EE11. If you want to, shoot me a note, or I can actually put the URL in the chat in a little bit. So this way, if you're interested in contributing to open source, this is a good way of getting started. And just so people know, contributing to open source doesn't always have to be code. Documentation is always important. And I've done a lot of that myself with Jakarta NoSQL. So, if you're not comfortable sharing code or contributing to code, you can always look at other things. And while we're on that topic, sometimes, you use an open source project, and I used a Micronaut script, and it wasn't working. I looked at it. I said, oh, I just got to change this. Did the pull request, boom, so just little things like that. If you come across open source projects, would appreciate this very much. All right, so let's introduce Cameron. So turns out we just talked about this before we went live, but it says Cameron Purdy is an 11x developer, so co-creator of the Ecstasy programming language and co-author of Oracle Coherence, and that is a in-memory data grid, I think, if I remember rightly, right, Cameron? Yeah. Cameron is co-founder and CEO of Simply xqiz.it, and the URL is xqiz.it. Previously, he was co-founder and CEO of Tangosol, which was acquired by Oracle, where he served as a senior VP for Enterprise Java, WebLogic, if anybody remembers that one, Coherence, Traffic Director, and Exalogic products. Cameron is a contributor to the Java language and virtual machine specifications, author of the portable object format, the specification, and author of a plethora of patents on distributed computing and data management. And also, I'm going to put in the chat a 30-minute interview we had with Ben Evans from InfoQ about a year ago or so, maybe a little bit more than that. But that might be, I think if you're interested, it's a good read for everybody. So with that, I'll keep my mouth shut, and we'll send it over to Cameron. So.
All right, thanks, Michael. So I'm on Zoom. I know that some of the people in the meeting are on Zoom and some are on YouTube. So yeah, just ask that everyone on Zoom go ahead and mute just in case. And that should.
Okay. Moi, mon tonton Bonnia, tonton Capet, il est venu d'Abidjan avec mon cousin. Voilà. Donc,
okay. And so there's a little bit of delay on the YouTube side, so don't be surprised if you if there's some back and forth and it feels a little bit out of sync. I'd much prefer to actually be there in person because, normally when I'm speaking, I get to look at the audience and they smile or they laugh at, the wrong times. And I think that wasn't a joke. So it's a little bit different when you're kind of looking at a screen. And there's a little bit of delay on the YouTube side, so don't be surprised. So, sorry, just got some feedback. So again, these are a little bit different than an in-person meeting. So hopefully before too long, we'll be able to make it down for an in-person when we're not having I'm looking outside the window, a whiteout condition, snowstorm up here. So on the plus side, if you like skiing, it's going to be good this weekend. So yeah, I'm going to go ahead and share my screen. I have some slides, and I was really hoping to, oops, wrong button, put some more, I was hoping to get some more time updating these because we've been pretty busy since I originally put this set together. But what I'd like to encourage is if you have questions as we go ahead and put those into the chat, whether you're on YouTube or on Zoom, and we'll get those back. Trying to see where the chat is so I can actually pick those up. But Barry or Michael, if there are questions in either one, before we go on to the next slide, before we lose where we are, let's go ahead and get those questions into the conversation. And I'll be trying to jump out of the slides and into actual examples and discussion around that as much as I can, because slides are really no good substitute for for actually seeing stuff how it works. So so a little bit of background. I started working with Java back in '96, instantly fell in love. So the co-founder of mine here at xqiz.it, he and I started looking at it at basically the same time. I downloaded it, and within half an hour, I said to him, I am never writing another line of C++ code again in my life. It was that kind of cut and dry, because I could see that what Java was going to do for us was take away all the pain of C++ at almost no cost, right? At the time, it was still interpreted, Java was still interpreted. So it wasn't, it wasn't as fast as it is today. Obviously, it wasn't mature. There weren't even Java beans. There wasn't SWT or, Swing or any of the, there was no J2EE, there was no servlet, there was no nothing. It was, you had vector and hash table, and so there was no concurrent stuff. All the things that we take for granted today didn't exist yet, but you could see in the design of Java, you could see for lack of a better word, you could see the love of the people who designed it, how they put that into the design, how you could, it was so easy to pick up. It was so intuitive, coming from C++, it was as if I already knew the language, and it was a great experience. We never really looked back. I did have to write a little more C++ code, unfortunately, but I've enjoyed Java now for over 25 years. And the other thing I'd say is that at the time, Java was so far ahead of everything else that existed. I'll just apologize for any Smalltalk developers on the call, because obviously everything that's ever been done was done first in Smalltalk, and obviously done better in Smalltalk, but nobody knows about it. So we'll just set that aside for a second and say that Java was so far ahead of anything that anyone actually knew that it was just a giant gulf between the state of the art as people understood it and what we saw in terms of the promise of Java. And so it's been a long road in terms of I've now worked on several different Java products and quite enjoyed it all along. So I'm going to skip my introduction, since I already got that brilliant introduction. The only thing I'd point out here is the Darwin Award semifinalist. Moving on. So I want to talk today about a couple things, and in the summary I gave for the presentation, we're talking about the serverless cloud, and it's kind of an interesting concept because we all know that the serverless cloud isn't serverless, right? Like, there are servers there, right? That's the whole point of what the cloud is. It's lots of servers. So when we say serverless cloud, what does that even mean? Why would we come up with such a strange combination of words? And what's really cool about the concept of the serverless cloud is that the servers don't matter, because you're not targeting a specific IP or a specific machine or a specific virtual machine. The idea behind the serverless cloud is that the service, the capability of the cloud is such that whatever you're deploying into that environment has a home if and when it needs it, however it needs it. And it's provided, the capabilities that you provide in your application or in your service, those capabilities are easy to expose out of that cloud environment, because the management system of a serverless cloud is responsible, for providing it with the hardware it needs, and for providing it with the operating environment that it needs, and the networking and so on. And so, if you were to go back 15 years and think about cloud, this concept of the serverless cloud didn't exist, but you could see the roots of it coming, right? I was interviewed about the time that Oracle acquired our company, and someone was asking about Amazon, and I said, well, it's really easy. I have a dozen servers I can test on, but if I need 100 servers, how do I get them? And with Amazon, I could give them my credit card and have a couple hundred servers, for a few bucks an hour. Obviously, the prices have gone up, but back then, that was a pretty significant and amazing thing to see. And so, the evolution of that pay as you go, if you will, that ability to go online and grab a machine and deploy to it, that evolution into the serverless cloud is an evolution about how does that capability erase the complexity that's associated with it. So the serverless cloud is about erasing complexity. That's a good way to think about it. It's about being able to forget, even though you know it's still there. It's like being able to forget about the specifics of a server deployment. And so that's what we set out to target with our design. And the reason is there's a bunch of different reasons, but the first thing is when you're putting your applications and your data and your user interactions and everything else, when you're putting those into a shared environment, like a cloud environment, I mean, the first big red flag that anyone raises is, what about security? And what about, how do you know our data is going to be safe? And, how can we trust this environment? And so, so we look at security as being kind of the fundamental factor of what enables the adoption of cloud technology. But the other one is kind of the flip side, which is about efficiency. In other words, when clouds first took off from an economic point of view, there was an economic efficiency, both from the point of view of the provider and from the point of view of the consumer. In other words, the ability to virtualize significant amounts of hardware workloads onto a significantly reduced hardware footprint through the use of virtual machines and eventually through containers. It was a very compelling economic advantage from the point of view of the consumer. And from the point of view of the provider, it was also possible to do that through the use of autonomic management of that environment and so on. It was possible to do that and still have pretty significant margin to build a business around that. And that's what we see with Amazon today. Amazon is a cloud company that just happens to sell things and ship them around the world. But for the most part, the predominant portion of their business in terms of profitability comes from their cloud infrastructure. So when we look at density, we're talking about efficiency, right? So one of our goals is what we call zero carbon compute. Now, it's not zero, of course, but what we'd like to be able to do is to take an application that 20 years ago needed its own machine, 10 years ago needed its own virtual machine, now it might just need its own container. And we'd like to shrink that down even more. So an application that's not under load, an application that's not currently busy doing something, we don't want it to be using any power. We don't want it to be using any footprint whatsoever. And at the same time, if it needs to scale outside of that, outside of some natural envelope, we want to be able to scale that application up very quickly to provide the hardware resources and the other resources it needs. And to do this, we have to understand, the CPU utilization of an application, the memory utilization, what it's doing on I/O, and we have to understand that in real time. And that's because as we deploy applications, today we have to size the deployment based on, if you will, the worst case scenario of the application. So if an application, you deploy an application onto an 8 gig VM, if it ever needs 8 gigs plus 1 byte, it's going to blow up and die, right? Like it runs out of memory, there's now a memory error, it crashes, right? You have to restart the whole thing. And, so how do you make sure that it both fits into the environment? But what if it does need more memory, but only for a certain portion of time, right? So it's important to be able to enforce hard resource limits, but it's also important to be able to expand and contract the footprint of that application dynamically. And it's also important from a management point of view. If something's going AWOL, you want to be able to kill it, not just ask it to shut down. You need to be able to kill something. You need to be able to and if something's not busy, you want to be able to place it on disk until it's needed again. And so these are all parts of achieving what we call secure density. Just to give you a kind of a order of magnitude for what we're targeting, we're looking at machines that are likely to have 1,000+ physical concurrent hardware threads, on the order of 30 terabytes of RAM, and we're looking at actually being able to consume that entirety in a single process, and to be able to subdivide that across potentially thousands of concurrent applications. So the virtual machine that we're designing, which today runs on top of the JVM, that virtual machine is called the XVM, and that runs the software we're about to look at. So let's get into that a little bit more. So the first thing is that within this virtual machine, all the code running in that virtual machine is running inside a container inside the virtual machine. So when you start up the virtual machine, the first thing it does is create what you think of as a root container, right? So that's the container that has all of the capabilities that are allowed, that are given to it as it started up, which by default means that, the capabilities of the user, that begins that process. And then, that container has the ability to create, nested containers within it. And then it can provide the capabilities to those nested containers that it chooses to provide to them. And that allows, for example, an application to be hosted within that environment without having the full capabilities of the machine or even the full capabilities of the user. And one of the benefits of that is that multiple containers can be created and multiple applications can be hosted within that same environment. And within a container, the code running inside the container actually has no access to anything that's not explicitly provided to it. In other words, it has no I/O capabilities. It has, it can't touch the network. It can't touch the disk. And the benefit of this is that, only from the outside can those capabilities be handed to that container. So when we form a container, we basically take the type system from the application and we transitively close over its dependencies. So whatever other modules, whatever other libraries are needed by that application, we group those together into a type system and we form the container using that type system. Then within that type system, we create what are called services. And services they're very similar to threads in that each service is capable of running at most one logical thread of execution at a time. And in fact, this is one of the reasons why we're really excited about what Java's done in the latest releases with the support for fibers, because the way that we actually execute code within a service in Ecstasy is on a fiber within a service. So now we actually have from Java, we have the ability to actually mount that directly onto the JVM using the fibers available from the JVM, which is extremely exciting. So what a service represents is actually a realm of mutability, meaning information is not globally available across all the code running within this process, or even across all the code running within a container. Each service represents a domain of information, and that information is owned by that service, so that anytime you need access to any of the information within the service, you actually have to send a request, if you will, into the service. The service then processes that request when it's able to, and it responds to the request. And as a result, because the service is only running at most one fiber at a time, there's no race condition naturally within this environment. There's no shared mutable information. So one of the challenges with a high concurrency environment is that information is being, both read and written by any number of threads. And in this case, what we've said is instead of having that highly concurrent, everyone's reading and writing from the same information, we're going to subdivide the information into these services, and then access to that information has to be achieved by routing requests into the service itself. And it is able to do this without anything like a wait or a synchronized or anything like that. And in fact, from the user's point of view, it's from the developer's point of view, it's just a call into an API. So I'll definitely do some examples of this. And in fact, just to introduce some. Let's see, just to give you a brief look at what what some of this would look like. Let's go down to some of these examples. So what I'm actually pulling up right now, this is called the XDK. This is available for download. But the examples within this are fairly basic. But of course, the first example you always have to look at is a hello world example. And as you can see, looking at this, it's inspired heavily by the Java language. Now, we wouldn't have actually created a language if we could have gotten away without creating a language. But some of the features I'm going to show you today and talk about, driven by the serverless cloud environment, these features required support in a runtime to achieve them, particularly around security, particularly around density. And so we had to design a virtual machine to provide those serverless capabilities. And then once we designed that, we had to have a language that would actually target it. So what we did is we used all the things that we knew from Java and similar languages, and simply built them into something that supported that service model and that container model that I've been describing. So if I can get my keyboard to work, it hasn't been cooperating today. So let's see. Here we go. That's not a good sign. That's better. So let's see. So I rebuilt the XDK earlier, so it confused the Mac operating system. So what we're going to do is take a look at the Hello World example. We're just going to compile it using XTC, then we're going to run it using exec. And as you can imagine, it prints hello world. That is the if I were in person with you, you would all be standing on your feet applauding at this point. Because I'm told that my font is too small. So let me increase the size of my font. And as you can see, I'm also using IntelliJ. Is there a font? There we go. Hopefully that's a little better. Okay, so I want to talk about few things. I'm looking at this code. One of the things that should jump out is this line right here. We're injecting something, and this is one of the beauties of the container model. So when we start this, when we ran this program from the command line, this was the initial container that was being created, and so when we executed this code, it had access to everything by default that the user account that's running it would have. And so when it says inject a console, what that means is I know within my container, I don't have any ability to read or write to the terminal, to the console. I need that capability, so please inject it. And so what happens is then the runtime pushes into the container an object that has the capabilities of a console. Now, what's really cool is if I tried to look at this console, for example, if I change this this code to actually say, what the console is, I could look at the what the console object is. And if I ran that again, it says, I'm the terminal console, but there's no capabilities of that console in addition to this interface. So if we look at the interface for the console, it has the ability to print and it has the ability to read a line, and that's it. So it allows us to take functionality from outside the container, push it into the container, and only the functionality of that interface is available. And the reason this is so important is because the code running in the container may not be trustable, right? If you're hosting, for example, applications, you could have two applications. You don't want one application to be able to, violate its container and look at what's running in another container. And so by having none of those capabilities naturally inside the language, inside the container itself, everything that's running inside the container has to explicitly ask for the capabilities it needs or wants. And what's really nice then is that, for example, if I'm running this in a multi-tenant environment, I don't want the applications there to be able to print to the screen or to be able to read from the disk or just connect to anything over the network. So instead of injecting the actual console, the actual terminal console into the application, I may inject a logging console that logs information on behalf of that application, so that the deployer for the application can then come in and see the log of things that have been previously written to the console. Similarly, if I have 10 different applications deployed on a machine, each one may think it has access to the file system on that machine, but we can provide each application with something that implements file system, but is specific to that application. And in other words, we could store all their information in a particular directory, or even in a single file, or not at all. This is particularly helpful when you're doing things like testing, when you want to be able to test a piece of code without actually impacting the environment that you're testing it on. So, for example, you want a repeatable test that always starts with the file system in a certain state. It does a bunch of changes. It thinks it's changed the file system, but when the test finishes, all of those changes can be discarded, after they've been analyzed for the purposes of the test. So, so this container and service model allows us first to completely encapsulate a running application in a secure manner inside of a secure container, providing it just the capabilities, the bare minimum capability it needs to do its job. And it also allows us to avoid a lot of the challenges around building concurrent systems by avoiding things like race conditions and shared mutable information. All right. Just go on to the next slide. So, so there is a dramatically different memory model at play, as you could probably figure out from the last couple examples that we've talked through. Allocations don't happen at the VM level. Allocations happen within the container, and in fact, within a service. So at any point, I can know exactly how much memory a particular container is using, because that container basically rolls up all of the services within it and all the containers within it. So I can, on a real-time basis, I know exactly how much memory is being used, how much CPU is being used, and so forth. When an allocation happens, it's happening, there's a piece of code that's running and it allocates some piece of memory. That allocation happens within the service that's running the fiber, that's running the code that does the allocation. And so this means that we can actually look all the way down to a service level and see exactly how much memory it's using. And this is particularly useful when you're trying to limit or schedule workloads based on how much memory that they need. For example, you may have to move an application from one machine to another to make sure that it has the resources that it needs to execute. So within the VM, we do the allocations at a service level within a container. And then within the container itself, we have immutable information, which is shared among all of the services within that container. And what this allows us to do is to garbage collect at the service level instead of at the VM level. And then the garbage collection for the immutable information can be done in a non-blocking manner because the information is immutable. We can copy compact it without dropping the old copies until all of the users of those copies have acknowledged the relocation and the GC. So this is a pretty old trick that was originally tried, I believe, in JRocket. They had a very similar GC mechanism for immutable data. Let's see. So I'm going to do a quick example of what we're talking about here, which is how services communicate one with another. So I'm going to whip something up pretty quickly. So as you can see, everything is done within a module. Module compiles to something that it's very similar in concept to a jar file. It basically means everything I need. So what I'm going to do is I'm going to create a service class. Now, what a service class is, it's like creating a thread or something like that. We'll just call this service printer. So this is going to print something for us, and that's pretty simple to do. We'll stick it in we'll create a printer from our console, and then what we can do is we can tell the printer to print. So we'll make an extremely simple example, just like hello world. And so within here, we'll do our void print. And as you can imagine, the only way we can print is to print to that injected console. So that's what we're going to do. And so as you can imagine, pretty straightforward test. So all we've done is basically created the equivalent of another thread to do our print for us. Now, that's not exactly a good idea, but the benefit is it's simple enough that I can actually get it to work the first time. So what we want to do, though, is we want to do something concurrently. So instead of creating one printer, let's create it with a name. So we're going to give each printer a name. And so let's go ahead and create a bunch of these. So we're going to create, say, 5 different printers. And for each one that we create, you'll notice the Java Lambda syntax here. We're gonna take that number of that printer and we're going to use that as its name. So we're going to take that integer value, turn it into a string. Actually, we can even do it as a template. So we're going to call it printer dash I. So now we have 5 different printers, and for each one, we're going to tell them to print a certain number of times. And what we'll do is we're going to do this very naively. We're going to just tell them to print something over and over. And so this printer has a name. And it's going to print its name plus whatever it's told to print. So when we run this, we know that each of these printers is a concurrent service. So when we print, we would expect them to all be printing at the same time, but we're actually going to be quite disappointed, unfortunately. In fact, let's go ahead and just stick this in a loop as well. And the reason we're going to be disappointed is that we're not actually calling it in a way that can be concurrent. We're telling it to print, and then we're waiting for it to print. And of course, I have a syntax error. It's because I didn't tell it to create the printer. So, as you can see, it just goes through the loop and it does it all in order, in perfect order. And that's not really what we wanted. We wanted these things to actually be running concurrently. And the way that we do that is we take a future, and there are 2 different ways to do that. We could say, for example, that the future comes from calling that function. So, for example, if it returned a string, we could say that this what we're printing will be the string, and it can return that after printing it. So we would say, future string s equals that. And what this does is it says you now have permission to run asynchronously, because I'm not waiting on you to give me back. I'm not waiting on you to give me back the answer. I'm actually telling you to go ahead and run, and whenever you get ready to, you can hand me back that answer. And there's a shorthand notation for this as well. But basically, 21. It's so picky that I have to actually use the right syntax. And what you see here is that the order is a little less ordered now, right? So we have 2, 3, 4, 1 instead of the zeros. So we have slightly, you can see some slight concurrency going on in this example. And so what I want to get across is that the information about a service, like its name, that's actually local inside of the service. It's not something that's visible outside of the service. I can always get it by asking for it, So for example, if I want to know the name of the service, I could just say, string name of service. And I could ask for that printer's name, right? But when I do this, it actually goes to the service and says, what's your name? So this is a property, and this is a method. And in each case, all of those things are owned by the service. So any use of them requires communication to and from the service. And the benefit of that is that communication is naturally ordered. And because it's ordered, we eliminate all the challenges due to concurrent access on that. So Barry and Mike, I just want to check, make sure we haven't gotten it.
We do have a question for Boris. When you say containers, do you mean Docker containers or XVM? XVM has its own container concept.
Very good question. So specifically, these are XVM containers, and I'll show you what that looks like. So this is an XVM container. And as you can see, it's a wall of comment. But a container is an Ecstasy object. And as you can see, it's actually an Ecstasy service. As such, when I create a container, it's independent as a service from wherever I create it from. And the way that I construct it is I construct it around a module. And this is what I was saying earlier about how we form a type system. So basically, I give it the application module. I say, I need you to host this module in a container. And I want to use a secure model for that container. If you need other modules, you can find them in this module repository. Anything that needs to be injected into that container, this is where it'll get injected from, this resource provider. I want you to share some modules that I already loaded. By default, the only module that gets shared is the Ecstasy module itself. That's where we define things like Boolean, int, string. So that has to be shared. Otherwise, we can't talk back and forth because we don't have any shared language, any shared notion of concepts. And then I can add a couple more modules to it that the app doesn't even know about. So maybe I'm doing some profiling modules or something like that I can add to it. And that's how I form a container. So when I construct a container, I also have the ability to control it. So this is how we link the file system for the container, which returns us the control over the container. And then here's the control itself. So I can tell it how to optimize what we call a target optimization for the container, what its scheduling priority is, and so on. I can limit the number of hardware threads that it can utilize. I can limit the amount of compute that it does, the CPU, and I can limit the memory. Now, these are not hard limits. What I mean by that is when it hits the limit, the application doesn't die. When I limit the compute, what I do is I say, hey, here's 10 seconds of compute time. You go ahead, use the 10 seconds. And when you run out of the 10 seconds, tell me. I'm giving you a function. You can call this function, it's an event, right? You can call this as if there's an out of CPU event. And if I want you to have more CPU, I just call again into limit compute, and I give you another 10 seconds and give you another event to call back when you run out. So this allows us, from either very coarse grained or down to a very fine grain, to be able to control the execution of a container without actually being involved in every instruction, right? So think about this limit compute, not so much as limit the exact number of CPU cycles, but more like in Java terms, you could think of it this way. When you do a safe point on the VM, let's update the stats. And if they exceed some previously indicated value, then let's introduce user code that has the ability to make a decision as to whether to continue or not. Same thing with memory, except instead of a duration, we have a maximum number of bytes. And the event, of course, is that you've exceeded the RAM. So this is how a container works. And then if you want to, from the outside, this invoke is how something actually runs inside the container. So, we've been doing this test where there's this code called run. The way that this method run gets called is from this method on the container. So we invoke a string called run, and we pass it either no parameters or whatever it needs, the command line parameters, etc. And so it can even return values from that method run. So this allows us from the outside of the container to tell the container to run something inside the container. So these are definitely Ecstasy containers, has nothing to do with Docker other than the name, the name container. So hopefully that answered the question. Yeah. So, why did we choose the model that we did for memory? Well, obviously there are two main reasons. One, we want to be able to manage the memory. So I don't think I've specifically said this, but our goal with respect to hosting is to be able to put around 10,000 separate applications onto a single physical server. So when I said, driving the carbon footprint of these applications down, 25 years ago, we were using a server per app. Now we're using, we might have 25 apps running on a single server now. And, we're looking to go to, on the order of 10,000. Now, these are lightly loaded apps because of course, you can't run 10,000 apps if every one of them needs, 100 gigabytes of memory all the time. But what you see in this model, in this language model that we're producing, is that the actual work gets done. And in fact, let's take a look at a web example. Actually put a little time into this today, trying to make sure I could show this. So this is Hello World for the web, right? And the idea here is that instead of, sitting in a loop waiting for a request to come in, you simply expose, and this should look familiar because you've seen lots of frameworks that turn it around and turn it into an event-driven system. You simply expose your endpoints, and then the server calls them. So this is self-contained. I mean, that's the entire application. So let me just walk you through it. First things first, you've seen annotations before. In this case, what web app is, all of our annotations, these annotations, are what we call mixins. So a mixin is like a subclass, except it doesn't know it's superclass. So mixin says, I'm a web app. I am willing to be mixed into anything that's a module. If it's a module, you can stick me onto that module like you can stick Lego together, right? And of course, when it's stuck to it, it has all the information it needs. It knows, like, let me see if I can spot a good example here. It knows that it is a web app. Unfortunately, I don't see a great example here, but basically it knows that this is both a web app and a module. So its compile time type is module plus web app. This is what we call a type calculus, in that we can form more complicated types out of simpler types. And so what a web app does is it allows us to mark this module as being a web application, but it also allows us to put the logic and the interface from this mixin into the module itself. So all the methods that you see here, everything you see here, is glued onto this module. And what that allows us to do, as you can see here, just ignore the to-do. We don't actually have any to-dos. I'm joking, of course. What it allows us to do is to pre-create functionality in blocks and then glue them together to achieve what we want to do. In this case, it allows the web application to provide its own authenticator for HTTP authentication. So for example, we could use a basic auth, right? So a basic authenticator, again, not surprisingly, a basic authenticator is a service, and it's a service that when it needs to authenticate, it tells the user via header on a response, it says, hey, you need to authenticate for this realm. And then the client will then send back a response with an authorization header that says basic, and then we'll decode that response, and it has a colon in the middle of it with a user and a password. We'll validate that against the realm, and that allows us to authenticate the session. I mean, there's a little hand waving here, but this actually works. It took a long time to make it look as simple as it does, but it is actually just as simple as it looks. And then, of course, what this is, just so I don't miss any of the explanation here, if we fail to authenticate, we tell the session that we failed, because the session actually will keep the session knows about the IP address and things like that. So it actually keeps all the denial of service statistics, things like that. So we can detect when someone's trying to, brute force an account password or whatever. And it allows that information to not be lost, but it doesn't penalize the entire system for it. It tries to focus it in on the specific session that's causing the problem, for example. So going back to the mix-in concept, when we mix in a web app, this hello server becomes a web application. We're just going to grab a couple other libraries. So we have the Ecstasy library, which is implicitly present, as I was describing earlier. And then we have the crypto library, which we need for the this is our SSL key. This is our top secret password for our SSL key. And then we're going to host this on localhost 8080. So Xenia is a Greek word that means hospitality, basically. It means to be welcoming into your home, if you will. So we're hosting the server on localhost. And then this annotation, web service, similar to how we annotated the module, a web service mixes into a service and basically marks it as being able to provide endpoints for the application. So if we want to take a look at another mix-in, as I mentioned, web service is a mix-in into a service. And I haven't looked at this in a couple months, so I'm going to pretend I know what I'm talking about here. But basically, it has a way of discovering it's the web app that it's contained within. It also provides storage for the current session and request. Actually, this is a really good example to talk through on the topic of the memory model, because this is a perfect example. So when I get a web request coming in, I'm going to hand it to a session to execute. So that session, I'm going to hand it to a web service to execute. And that web service is now executing that request on behalf of that session. Now, if I get another request that comes in, what do I do with that request? Well, I could queue it up, make it wait, or I could just say, create another one of these web services, just new it, right? And so what this allows us to do is to achieve concurrency in a very controlled fashion. We could say limit, for example, the number of concurrent requests to 10. And that allows us to consume, via 10 different services, it allows us to consume 10 physical hardware threads from that CPU. But it allows us, within that container to constrain our usage. So we're not just going to try to execute 7 million things at the same time. But similarly, we don't want to just do one thing at a time, right? So it allows us to mix between the concepts of queuing and concurrency to balance and find that optimal trade-off between the amount of CPU that we're utilizing and the amount of memory that we're utilizing, and so on. So, and what you see is that this is actually what we call when we dispatch a request. We tell the web service, hey, web service, I need you to route, for this session, for this request, to this handler. This is the thing that actually needs to get executed. And if you have an error, this is what you do with it. And so what you can see, using something very similar, this should read very easily for, it's almost identical to Java in this case. What we're going to do is we're going to store off the session and request so they're available, if you will, from anywhere within this web service. Then we're going to run the actual, we're going to delegate down to the handler for the request. So we're going to handle the session request. It's going to produce a response. We're going to freeze that response so we can throw it back to whatever container, whatever service called us. And then we're going to clear out the session and request when we're done. So, so this is where the concurrency comes from. For example, when we're running web service workloads.
So, question.
Yes.
Mixins are kind of like Scala traits.
I have used Scala some. I'm not entirely certain. I think Scala traits are kind of like interfaces, I thought, but I believe yes, I believe Scala traits are similar to mixins. Yes, that does sound right. Let me see. Just because as I mentioned, I previously built this also just in case of stuff. Oh, it is here. Okay. No, I don't want this one. Where was I? These are the XDK examples that we were looking at before. So let's go ahead and compile that server. And now we'll execute it. All right. I was going to actually, when you're talking about, I was going to tell a joke earlier, so I'll put it in now. The someone showed this to me recently. So you may wonder why I have facial hair. I actually hate it myself, but this is why. You can't make a language without facial hair. So it must be the beard.
It must be very, very brave to have facial hair, even though you hate having it, just for that joke.
Well, someone near and dear to me loves my facial hair. So I don't know how many of you have this on your face, but it itches all the time. So I would cut it off in a heartbeat. So I just ran the localhost 8080. This is what Firefox does with a JSON response of a string. It shows me hello world. And so I want to go back to show that code. That was hello server, right? Yeah, hello server. And as you can see, there's a method called say hello. It's decorated with a get. I believe this get thing actually came from one of the Java libraries that we've seen before. It was actually this is actually prototyped by one of the Helidon developers. He prototyped the Ecstasy implementation for us. So thank you. And what you see is that this method, which returns a string, this is a shorthand notation to just return that string. So say hello returns hello world, and that's what we saw over here in the browser. And then I don't know if I want to run this one right now, but this is the we did the server. This is the client side of it. So all it does, we pass some args in on the command line. By default, they are localhost 8080. We print out what URI we're accessing and what the server returned. So here the server is still running. I think I have another window. Yep. Gonna have to do that trick again. Hey, it's back. So now I'm going to XTC the hello client, and I'm going to exec the same. So the server returned hello world, and there's what a client application looks like. Let me get back to the window I was in. There we go. So and again, as I mentioned, everything that touches the network or touches the disk has to be injected into the container. And what this allows us to do, for example, is to protect an application from accidentally leaking out data. So you can say this application should only be able to contact, Google, Facebook, Microsoft, because we're going to use those for OAuth. But other than that, don't allow any outgoing connections, just as an example. Or similarly, you can whitelist or blacklist any of the. I think they're updated terms for that, so I apologize if those are no longer the terms. But you can select which IP addresses, et cetera, that you would allow to actually come into the application as well. So what that means is when you say, inject me with a network, what that means is when you get a network, it's not the entire network of the hardware you're running on. It's the network that the container above you decided you should have. And the benefit of that is, if you ever need to debug something, you could wrap the network that you're putting in with something that logs certain information. And you could inject that logging network into the application. So every time the application wants to do something with the network, the container above it has the ability to intercept that functionality if it wants to. Obviously, intercepting functionality slows stuff down. So you're only doing this when something needs to be secured or logged or whatever. So the idea is, you only pay for, in terms of performance, you're only paying for the things that your application actually needs. All right. Were there any other questions on this before we go on? I'm going to guess that's a no. All right. So I really want to get through a bit of this. So here we are. So I already described this. Everything's injected. Even the clock is injected, right? So, you think about timing-based attacks and stuff like that. Well, you don't have access to the CPU clock. You don't have access to the RDTSC instruction or any of that. When you say, I need a clock, you get the clock that's provided from the outside. And again, this is great for testing. If you want to test it with everything controlled, you could inject a clock that always gives the same answer, for what time it is for every test run you ever do. When we inject, as you saw in the console example, for example, we inject by type and name. And there are only two things that can be injected. One is a service, and the other is immutable data. So I could inject, for example, a configuration, timeout seconds or whatever. It's a constant value. It's immutable. And the only information that can flow in and out of a service or a container is information that is immutable or a service. And when a service is passed to another service, it's not passed as a simple object reference, like you would a regular object, say in Java. It's actually passed as a proxy to the service. So that proxy represents the ability to achieve the asynchronous behavior that we've described, the support for future handling, and so on. So, if it's a message-based communication, the proxy represents the message-based communication. And that's all encapsulated in a reference that looks like, if you reflect on it, that reference looks like the service that it represents automatically. So, in Java, we used to do this with dynamic proxies, for example. We'd have some object and we wanted to mock that object and pass it somewhere else. So we'd create a dynamic proxy for it. So in a way, this is like a dynamic proxy that goes potentially across multiple threads. So big picture goal, I think we talked a bit about this. We're looking at least 2 orders of magnitude improvement, particularly for low load applications. And autonomic management, the ability to take these and automatically spin them up, automatically park them on disk when they're not busy, and to both measure and also modulate the resources that they have access to. So this is an architecture that's designed explicitly for autonomic management within a ridiculously complex data center running potentially millions and millions of applications. And when you get problems that are that complex, as you've seen with Kubernetes, as you've seen with Docker, the key is both in terms of automation, to be able to deal with that much complexity, both in terms of automation, but also in terms of automatic, or as we call it here, autonomic behavior, where the system itself is responsible for the decisions based on the goals that have been provided to that system, in terms of what are the priorities for the system to achieve. I mentioned, when I first picked up Java in '96, I downloaded it from Sun. I think this was a little before they came up with JavaSoft, so it was still Sun. It was the beta for 1.0. You download it, you unpack it. It actually had source code inside, and coming from the Windows universe, that was just unheard of. Source code, who would ever show their source code? And it was readable. Like the way I learned Java, because there were no books at the time, like as a brand new language. The way I learned it was I just looked at the code. I read hash table, I read vector, I read everything that they had code for. And at the time, it wasn't yet open source, and they only had some portion of the code available as part of the JDK. But it was just so easy to read coming from C++. It was natural. And how many developers get to only work in one language, right? Like, yeah, it happens, right? But you need to be able to switch. At Oracle, I was often looking at C++, Java, and C# all in the same day, right? So it's and by the way, that's not counting front end, which is some combination of HTML, CSS, and JavaScript, which is a form of torture. That's what we do to people we don't like. We make them use JavaScript. So you can see that part of the goal that we had here was just making it very, very easy to switch, very easy to learn, based on what developers would know from coming from a language like Java. Modular from the ground up, designed explicitly for the serverless cloud, servers in a serverless cloud, and eventually. So I want to be clear. This is not none of this is done yet, but we want to get to the point where this technology is deployable as well across the client tier, and it's a natural conclusion. So I think you've already seen basically how we organize modules. I'm just going to walk through a couple real quick. I don't know if real quick should be in my name because I always go off on tangents. But here you can actually, so this is the library that contains that server that we were talking about. And what you see is at the root of the source, so source main X, we have the module. And this is what a module looks like, just like the test module, except more lines of code. And this is how we bring in other modules. So if you've ever done a ln -s in Linux, you create a symbolic link. You can use that to mount a network directory, for example, into your own file system. We're basically doing the same thing. This module, because we're working inside this module is our root, right? Our root is literally called Xenia. And under that, we have a package called aggregate. But aggregate is a symbolic link to another module. So we create a package, aggregate, that imports an entire module into its namespace. So aggregate's namespace begins with the module, and everything under it is nested. And what this lets us do is, from within a module, we define what our external dependencies are. And those names each have a name inside our module that we can refer to them to. So we never again have to say this crap, right? We never have to fully qualify anything ever again, because we've brought it in to our file system, right? So you can see that we have aggregate, collections, crypto, net, JSON, web, right? And if we go look on the left side again, we also have tools. Well, that's a package, and tools has templates, and that's a package, right? And then these here, these files are all classes and interfaces and so on under that root Xenia module. So for example, the dispatcher is the thing that actually handles the concurrent dispatching of incoming requests. As you can see, it's a service. That's the first clue that it's going to be used in a concurrent way. This is the catalog of information that we generate using reflection out of the web application. And then the server calls dispatch. It says, hey, I'm your server. Here's your request context. It tells you everything about the request. This is whether or not the request was received on a secure channel. This is the URI string indicated on the incoming request. And this is the method name. I assume that's get, put, etc. And so as you can imagine, it's a web server, so there's a lot of code, but basically it's parsing the incoming request, looking for a matching endpoint. And if there's no endpoint, it raises an error. Among other things, once it finds the endpoint, it has to make sure that if the endpoint requires TLS and the request didn't come in with TLS, then it has to redirect to a TLS URL. So it automatically redirects from, say, HTTP to HTTPS, for example, or from WS to WSS. Similarly, it looks up the session, so based on the request information, it gets either the session back or an error, right? And if it's an error, I'm sorry, let me explain that real quick. So this is part of the type calculus as well. So this says literally the thing that comes back is either a status or the session. Hence the or. And by the way, it's not ever null. There is no null unless you explicitly put one in. Okay, so I told you I'd get off track. So that's what a module looks like. And they can be much bigger as well. I mean, if you look at the root module, which is Ecstasy, this is where we define things like object, for example. So there's the object interface, which is very similar conceptually to Java Lang object, except it doesn't have anything for synchronization or stuff like that. And as you can see, there's quite a few sub packages here. Very interesting, since we're here, is to look at what null actually is. So this is the object null right there. That's how we define it. So we create a type called nullable, which is an enumeration that contains one value called null. And if you don't explicitly declare something as being nullable, then it can never hold the value null. And that's how we just avoid ever having, we literally do not have a null pointer exception. There's no such thing. So that was completely designed out. All right. So when we start, source code starts with .x. When we compile it with the XTC, which is the compiler, that produces a file called .xtc. And as I mentioned, the module dependencies get mounted into the module just like you would in a Linux file system with a -s. All right, any questions before I go on?
I think we're good for now.
Oh, all right, so let's get into the fun stuff. How are we doing on time, by the way?
I do have a question here. What is the X extension, the .x extension? Is that source files for Ecstasy?
That's correct. That is source files for Ecstasy. Yep. So, yeah,
and .xtc?
That's the compiled form. So the compiler emits. So let's go back to the example test. So this is test.x, that's the source file. And so as you can see, there's test.xtc. Let's just delete that. So when we say XTC test, we could say test.x, but it figures it out. When we say XTC test, it compiles that to test.xtc. So when we run it, we could just say test, but this time I'll say test.xtc. That's where the bytecode, the equivalent of bytecode, is in this file. So that file actually contains everything you need to both debug and run this program. So it actually includes the source code. So if we wanted to debug it, what I'm about to show you is just a prototype because we don't have a graphical debugger yet. So let's just put a debug in here. Here, we know it contains hello, so that'll drop us into the debugger. Contains. I'm in the wrong language again. This is one of the joys of working in multiple languages every day. All right, so when we run this now, I spelled it wrong. And I messed something up. Okay. It's just assert. Okay, it drops us into a text mode debugger where we can see that this source code is where we are at in that method. So we can see that we're inside the printer service. So there's a, this means we went through an asynchronous boundary into a printer service, and we're on line 25. So if we go back to the source code, you can see that this is line 25. And that's where we are in the debugger. These are our local variables and our debugger watches. So welcome to 1990 era debugging. So
Cameron, we have a question. Can you execute Java code from Ecstasy?
That's a very good question. So no, you can't. And it's not that it's not possible to add that via injection. It's that the focus that we have with Ecstasy is complete control for security reasons over what's going on inside the container. If you have access to anything else in the layer cake, you know, the operating system, the firmware, the CPU, whatever, even Java, that allows you to naturally break out of the container. So those are things that we have not built. A developer could build them and inject them into Ecstasy. So basically anything that is not pure Ecstasy has to be injected into the container. So all those capabilities are possible to inject, but we haven't done anything ourselves to enable direct Java integration, and that's because our focus is on the secure. And my computer just switched to dark mode. If you're curious, what's flickering? Must be that time of night. So that our focus is on a secure hosting environment. And I just want to be clear, everything I'm showing you is like open source. It's up online right now. Like there's nothing here that's like my outside of the test.x file that I just whipped up tonight, everything you've seen is online. So this is all available. Okay. Just a couple quick points. Everything nests. I guess that's the easy way to say it. If, for example, in here I needed another class inside this method, I could just say, class C. This extends. I don't know, whatever. String. Yeah. I could just write this code right here, and then here I could just say new C. This is obviously not going to compile because I just ripped it up, but it gives you the idea that any of these things can nest inside here. So I could create a service inside a module, or I could create another class inside of here. So, this is particularly handy when I want to have something that would be useful within the scope, but I don't want to pollute. I don't want my design to leak out. It's not a security thing. It's not like private is not a security thing. It's nothing like that. It's just about saying, this is the only place I'm using this. So this is the only place I want to see this. And it allows you to keep things much cleaner just by putting things exactly where you need them. So I could define an enum here, or I could define quite often, like if I just search, enum status or something like that, like we'll have these all over the place, and quite often they're only being used inside a particular service, or inside this is inside a particular class, right? Like, so we get in the habit of putting things only where we need them, and a class is relatively low cost, right? It's just metadata. Yeah, it has to compile down to something, but it's pretty cheap. Enum is just singleton instances of a class, right? It's cheap. It's very cheap. but it allows the code to be, much more readable. And it means I don't have to come up with exaggerated names to differentiate, 53 kinds of statuses, right? Because I'm only using them where I need them. So that's what it means about nesting. And as you can
Cameron,
see, yes.
Question? Actually, this one's mine. Can you nest functions within functions?
Absolutely. Yeah.
And I don't mean with lambdas. I mean.
Yeah. So a lambda is just a shortcut notation, as it is in Java for a function. So let me think of where we have a good example of this.
Well, I mean, for example, inside of the run function.
Yep.
You define a function within those braces
You
with the
bet.
same syntax.
You bet. Actually, so this is a lambda, so obviously we did that. But we could define another method. So this is a method on the module. We could define another method here called foo, right? It's just a method.
Yeah, that's cool. I missed that from the ancient days of Pascal.
And of course, I can define a function. Now, a function, we use the same syntax as Java does for a static method, but in Ecstasy, this is actually a function. And I'll show you what I mean. So this will be in bar. Okay. So now, if I say, we have var and val. So if I say f1 equals foo, what does that mean? Well, it actually means take this method, bind it to the singleton instance test, and give it to me. Actually, I don't know what it's going to bind it as because I said val. So I'm going to explicitly say I want a function that's a void function that takes no parameters, f1. Get me foo as a function. And now I can do the same thing with bar, right? So I could call these, and I could say foo. And I could say bar. And I could say F1. And I can say F2. And you know exactly what it's going to do. Do I have this set up? Yep, there it is. That's easier than switching screens. So did that answer your question?
Yeah, that's nice. Thank you. A question from Robert. Does ChatGPT speak Ecstasy?
I doubt it. I don't know. I've only used ChatGPT once, and it's brilliant stuff. So I don't want to. It's more a time limit for me. I'm too busy arguing online to use ChatGPT, but it would probably help me argue online better. The only time I've used it is for tech support. I actually needed help with a keyboard, if you can't tell, and it tried to answer my question. It didn't. It wasn't correct, but it was really, really amazing, no matter how you look at it. Right? I'm just going to say in lambda. Will that work, or do I need to return? Did I do? Oh, I didn't call it. So it used to be we would have to return because there's a lambda, but it knows it's void. Cool, very nice. So there we go. So these are all functions, but foo is a method, which means to turn this into a function. Here, as you know, I like going off script. So when I have a method, it's a method against the class or the type that it's part of. It has parameters. It has return values. Values, by the way, did you notice that? We'll do a quick example. To turn a method into a function, all we have to do is bind its target, which in this case is the module, and that gives us a function back, and that's how it works. So, yes. So let's take a quick look. I know what I want to do for an example. All right, so before I move on, this all made sense? We're good?
Looks good from the point of view of the chats.
So now what I want to do is I want to look at, this is totally unrelated, but it's a segue into that, what I just showed you, the multiple returns. This is an iterator. It's an iterator of some element type, and it basically has one function, one method. This returns a conditional element. What that means, you've probably heard of option types, maybe option types, option maybe types, I don't know. Those are all basically ways of approaching the same problem. Or, you know, if we look at Java's iterator, there we go. We have two methods. So instead of returning a Boolean in one method and an element in the other method, we actually combine it and we return a Boolean and a conditional element. In other words, we return two values. And if the first value is true, then the second value is an element. If the first value is false, then the second value cannot be looked at. So think about the Java verifier, what the Java verifier does. When you load a class file, it's like, okay, I've got this list of 10 commandments handed down on stone tablets. I'm going to look at the bytecode. Does this byte implement all 10? Yep. Does this byte implement all 10? Yep. And it goes through every byte of the bytecode. It keeps track of all the flowing of types through the bytecode, and it makes sure that you never do anything you're not allowed to do. And that's exactly what this is. This says, I'm going to return you two values. And the verifier has to prove that if I don't verify that the first value is true, then I'm not allowed to look at the second value. And so how this comes into play, I'm just going to erase my beautiful code here. I'm going to create an array of strings, right? Let's have Barry and Michael, and Paul, and me. Just grabbing the names off the Zoom. So I want to iterate through these names. How do I do that? Well, I could say, of course, you know, the string name is names, right? What I'm going to do instead is I'm going to explicitly spell this in. So I'm going to have an iterator of string. Call it iter. I mean, this sure looks like Java, doesn't it? And then what I'm going to do is say while. I'm going to say I have a string name, and I'm going to use a new operator, which I think in Pascal we call gets, G-E-T-S. This is the conditional assignment operator. And basically what this does is it says there's two pieces of data coming back from iter next. The first one is a Boolean. Send the Boolean to the while. The second one is a name. Send that, I'm sorry, the second one's a string. Send that to the name. So the Boolean goes here. And if it's false, you just drop out of the while immediately, right? But if it's true, I get the name assigned to this variable, and then I can say, I did something wrong, so give me a second. That's impossible. It should not have commas. Oh, what an idiot. By the way, the idiot was me. There. I was like, how on earth did it have commas? I didn't tell it to print commas. Okay. So there's Barry, Michael, Paul, Nathan. So that's what an iterator is. An iterator is something whose method next returns a Boolean for my while loop or for my if, for my for, whatever, and a value that's string. And why is this so important? It's because this name is never, ever, ever null, right? Remember, we looked at null. It's not special. It's just an enum. But now let's introduce null. So this won't compile. Why not? Because null is not a string. I can't assign null to a string. So what I want to say is, okay, these are names, these are strings, or null. This question mark is the same as if I had said nullable or string. But since I don't like typing that, I just use a question mark. So string question mark names is Barry, Michael, null, Paul, Nathan. So now I should get a null pointer exception, right? Well, first I have to iterate until it could be a string, nullable string. And you get Barry, Michael, null, Paul, Nathan. So there's no null pointer. But let's find out. So I apologize for any of you that don't program in C++, but what I just did is I got the reference to that variable. And what I want to do with that reference is I want to ask it what its actual class is. I think this is the right syntax. Yeah, look at that. So I have a reference, and its class is null, and the rest of them are strings. But what I really want to do is I want to call something on null. So let's make this into a template expression. So I put a $sign up front and says I'm a template. I put the stuff, the expressions inside curly brackets, and those get compiled into the string. So for the class that, the toString equals, I'm going to call the name toString. Let's run this. So what we see is for the class null, the name toString is string toString. I should have called it instead of, sorry, I just got a reference to the method, so it printed out the method name. Okay, that's better. Pay no attention to the man behind the curtain. So what I just did was I called a method on null. Because remember, null is just an object. It's an actual real object, right? It's not a zero pointer. It's not the absence of an object. It's a real enum value. So I can call null toString. And there are a bunch of fun things I can do with a null, but we'll save that for another example. So I did want to make a couple points real quick before I move on from this. You were asking about how we nest things. Well, here I'm nesting a property inside a method, right? And it actually declares the property and initializes it, but it only initializes it the first time through. And so you actually see this here, what code is produced under the cover. We don't produce the source code, we produce the byte code. But basically the first time through, it says, oh, if I haven't already assigned this, then I'm going to assign it here. And what this lets us do, let's come up with a quick example. Foo. So I just need a void foo. And foo has a property it declares as num, and it's going to say foo has been called that many times. See if I can eliminate all my syntax errors. Oh, what did I do? Ah, yes, of course. So I'm on a module, and a module is immutable. So I can't actually modify this number. So, and I should have initialized it anyway, but we're going to just now put this in its own class. Not console, just C. So I will come back to that immutable thing in a second. So now if I call foo twice, as you would expect, assuming I don't have any more errors, it's going to say it's been called 1 time and 2 times, right? And now, if I do the same thing again with another one, it should say 1 time, and then this one should say 3 times, right? And there it is. So this property, if you will, is owned by this method, which is part of an instance of this class. So that's how nesting works. It allows you to hide information down to the level you want to hide it. So you could build an entire class hierarchy inside a lambda if you wanted to. Don't do that, please. I'm just saying you could. It's theory. I said I haven't really said this, but everything is an object. Let's take a look at this. So if we made this into a service, and this is Nanda, and I don't know, wait. I'm going to actually return the value from this service method before I've computed it. And now I'm going to inject the timer. And I'm going to say, hey, timer. I can't remember the API, so let me go look it up. Right. So delay and alarm. So after 10 seconds, I want you to do what? Let's go with 99. That's a good number. So now, I don't want to do that because that'll actually just wait. So I want to say that there's a future answer that's going to come back from my service. Let's call it N, so it's not too confusing. So this service, when I call foo, is going to hand me back a future answer. It says, hey, I have a future answer for you. I don't know the answer yet, but after 10 seconds, I'll know the answer. And so when I get the answer back, I get it back immediately. So let's say console before the call. In console print after the call. And at some point, let's just print the end and see if this works at all, because I probably have 43 different syntax errors. Yep, I need a semicolon right here. I need more semicolons. Who came up with the idea of putting semicolons in a language? Okay, so there's our before call, there's our after call. And now we wait. Did I put hours or seconds? It should be 10 seconds and we get our number 99. There we go. So what you see here is basically within this lambda, we supplied the answer after 10 seconds to that value. So the run, this code, at this point, it's trying to access a future. It says, I need the value for n, but the value doesn't exist yet. It's still a future value. So let's take a look at what's actually going on here. Let's see what n is, right? So n is some value, right? Let's just say var v, so we don't have to figure out the exact type. So v is some actual class. That's class equals. And let's do type. And what we'll see, I'm going to just change this to 5 seconds because otherwise we'll be there all night. But the actual class is an int. The actual type is an int. Notice that it waited to tell us that. And that's because, right. That's because it actually took the value of n and waited for it. So now I'm going to be more clear that this is a future var of n. And what we see, did I do it right? No. So future var, again, implemented in Ecstasy. What this is, if I can remember what I'm doing, is that this n here is actually, it's like a box that holds a value, right? Sometimes you want the value, and sometimes you want the box itself, right? So what I want to do is I actually want to get the box, and that should have been, I'm forgetting the syntax or something, because I don't normally do this. It's something that you do in an example, but not actually in code. So I'm obviously forgetting how to do this, so I'm going to have to, because I don't want to hold up the presentation. I'm gonna have to either remember it or come back to it. What I wanted to show you, though, is that we can actually look at the object that is the box. We can actually ask questions of the box before it gets the answer back. Oh, I don't want actual class. I don't want any of this, right? That's why. So this is, sorry, it was working. It's just I was asking the actual class of the value. I don't want that. Now I know what I'm doing. Okay, so if we go take a look at what a future var is, it's a mixin. Why is it a mixin? Well, think about it this way. There's no way to know how the VM is compiling what a variable actually is. It could be a register on the hardware. It could be some complicated object written in Java or C++, or who knows, right? Who knows what it is? So we don't know what a variable is. We do not know what the class of this variable is, but we still want to add functionality to it. So we want to mix in our future functionality into a variable whose class we don't know and whose class we can't know, right? It's a class that's hidden from us, right? It's some detail deep within a VM, right? But we can find, oh, remember I told you we can just do an enum anywhere we need it. Well, we have a completion on a future. It's either pending or it has a result or it has an error, right? And we have, by default, it's pending. And can we assign it? Well, not yet, right? Do we have a failure? We're going to keep track of what that failure was and so on. So this is actually the implementation of a future variable. And we can find out if it's assigned, right? So let's do that. This syntax I stole from Python. All you do is you place an equals on the end, and it says, "Oh, you want to see this variable, and you want to." So it's the same as saying, sorry, this is just the same as saying be assigned equals that, except I don't have to say that. So we're going to see if it's assigned, and we'll do it before and after that. And hopefully, finally, my example works. There we go. So it's not assigned. Then we print the value of n, which means we're going to wait until it's assigned in the future. When it's assigned, we print it. And then, of course, the assigned is true. Now, I want to do one more thing. Oops. V has a method called then do, because it's a future. And if I remember correctly, please, please, please remember the name of the method. So, as you can see, and in fact, what I want to do is I want to put this inside here. So now, nothing between the time that we saw this line and this line, nothing was running. And this is really important to understand. There's no loop sitting there waiting. There's no wait call. There's no nothing, right? In other words, we printed this out. Then we said, okay, when this future finishes, I want you to print it out and tell us if it's assigned. And then after that, we just leave. We just walk out the door, right? So here, this run has finished. It's gone. But inside the runtime, there's a little note that says there's a future that you have to do something on. And this service, which is like running on a different thread, we called it. It created a future. It set a timer. And it walked out the door. It says, here's your answer. In the future, here's your answer. And it walks out the door. So neither this thread up here for run, nor this thread running the service concurrently, neither one is doing anything for 5 seconds. There's just two little notes in the VM, one that says I have a timer. When it goes off, set this future. And the other says, when this future is finished, I need you to do this code. And that information just sits there waiting for something to happen. So what you can see is in an event-driven system, you can turn around the constant polling approach or whatever. You can turn it around to things that have to happen when some condition occurs. And the benefit of that is that application, when it's sitting there waiting for something to happen, I can look at the metadata of the running application and I see, oh, it has a timer that goes off in an hour. I'm just going to stick it on disk. And an hour later, I'll pull it back into memory. And in the meantime, it hasn't used any electricity, hasn't used any CPU. Yeah, there's a big wad of CPU it takes to write it out and pull it back in. But I'm only doing that right at the point where it has to run its event. And the rest of the time, that computer is free to be used to run someone else's code. Maybe they're running a big query and they need lots of RAM. So we can throw 100 gigs of RAM at them for a few seconds. And, so they can expand well beyond what they normally would have access to, because we can move other things completely out of their way. Now, yes, we don't do this yet, but we can eventually get to the point where we can take running code in the middle of running when it reaches a safe point and move it to disk, and then move it back and continue. But I mean, it's not, the details aren't that important. The important part is that the system can take the information it has about the reactivity needs of the application and can actually tailor the running environment, dynamically based on that information, and achieve, pretty significant efficiencies as a result. Okay. Any questions before I go on? I know I got like way off target there. How are we doing, Barry?
We're doing good.
Except we're running out of time, aren't we?
I think it would be good to make sure that we wrapped up soon, just so we have a good, nice, solid conclusion here.
Well, I think I actually got to cover these without actually looking at the slides, which I'm much happier covering them in code than the slides. So we talked about nulls and how things aren't null unless you say they're null. We talked about modules, how they're hierarchies internally, how everything nests, and how a container instantiates around a type system, hosts the services that actually host the running code within that container. We talked about enums a bit. We showed some examples of classes. We showed modules. A package is like a module that's inside a module, just like Java's package. C# calls this a namespace. It's all, the words are all interchangeable. We didn't look at const, so I'm going to give one quick example on that. So an enum is a const, and a module is a const, and a package is a const. And all a const is it's a class that when we create it, it's immutable. So here's a const, it's a point. I'll just delete all this stuff. I'm going to say that point P equals a point. This is my negative. 78, -12. And that's the class. You may recognize this concept because it's actually now showed up in Java as record. This is the new record types in Java. This is exactly, what many of us have been asking for a couple decades. So this is a const. Now, what's cool about it is by the time I get this P, if I say P.y equals 3, you can imagine what it's going to do. It's going to say, go away. That's an exception. Yeah. So a const is a const class. Modules, packages, and enums are consts. A service is kind of the anti-const. It's never const. It's always somewhere else. And we looked at mixins, how they work. We looked at all this, except incorporates conditional, which is really cool, but I'm going to skip it because we don't have time to show everything that's cool. Actually, I'll give just one example. I'm not going to run an example, just going to look at it. So an array, if you haven't figured out yet, by the way, everything in Ecstasy is built in Ecstasy. You saw that null was. But it's not just null. We also have Boolean. Boolean's just an enum. We have bit. Everything's made out of bits. So a bit is just made out of an int literal. And an int literal is just made out of a string. And a string is just made out of an array of chars, and a char is just made out of a uint32, and a uint32, of course, is a number that's made out of it's an int number. It's a number. I want just number. This one. And a number is just made out of bit arrays. But we already saw bits and arrays, and they're made out of numbers. So numbers are made out of arrays of bits that are made out of numbers, which are made out of arrays of bits, which are made out of numbers. So this is what we call the turtles type system, because it's turtles all the way down. So in theory, if you look close enough, a bit uses more information than is in our entire universe, but somehow magically it only uses one bit. Going back to the array example, so an array is built in Ecstasy. It's an array of element. As you can imagine, it's a list. And this is that conditional I was talking about. So when we have a byte array, so if I have an array of bytes, what this says is, if my element is a byte, I want you to automatically mix in byte array. So byte array does things like UTF-8 support and packing and unpacking, and it does all sorts of conversions. So I can take a byte array and treat it as a float 16 array. That's a view, and I can also do a conversion as well. So the conversions start with to, the views start with as, and you'll recognize this. If you try to do this in Java, you do it with a byte buffer, right? So a byte buffer allows you to view another underlying set of bytes. So you can view it as a float or as an int or whatever. So this should be very, very common, but it all boils down to this, that we have the information about what is in the array, and we actually change the class. Well, not change. We form the class based on the type of its element. And that's incredibly powerful because it allows us to customize what each one of those does. Okay, so that was that. I think we are very close to all of it, and on and on and on. We looked at inject. We didn't look at lazy, but that's another annotation that lets us do lazy calculations. So all we have to do is say lazy, give it a lambda, and it'll compute that when it's necessary. And as you guessed, it's written in Ecstasy. It's just a mix into a variable. So when I say get on that variable, if it's not assigned, it stores the result of calculating off that lambda. And that lambda was the one passed in, as we saw. Just like that. So lazily computed fields, we don't have fields, but lazily computed properties, lazily computed variables, and so on. Anytime you don't want to write code, just put to do. It'll blow up if it ever hits it. You can even use that as an expression. So you can delegate an entire interface to do. So you can mock something in one line of code. You say delegates, input stream to do. So anytime it hits any of those methods, it blows up. Yes, that's mocking. And then you can pick which ones you actually have to implement for your tests or whatever. No time to run through this. That's a very complicated advanced feature, virtual child classes. Oops. We didn't look at operators, but as you can imagine, if int and boolean and everything else are implemented in Ecstasy, then obviously the operators on those are also implemented in Ecstasy. We could just keep going on and on and on. The type system is fully reified. There's no type erasure. We support covariance, contravariance, but intelligently, it's not willy-nilly. Again, these are advanced features, but you the benefit of the way the design works is it's just not frustrating when you're using generics. You'll notice we don't have any of the generics extends and generic super question mark stuff, or even the in and out stuff used in other languages. So we dramatically simplified generics. We do bidirectional type inference. We support auto narrowing types by default. What this means is that when a class like list has a method on it that returns a list, it really means that my subclass will know to return an instance of that subclass. So it's an auto narrowing type. So that's very useful when you're building container types. We support named arguments, default parameter values, multiple return values we looked at, and you can even add parameters and return values on function overrides. So it's quite powerful for evolution of software over time. And yeah, I guess the pros and the cons. The cons are curly braces get their own lines. It's a joke. We do use curly braces and semicolons, so we're still in that same Java C style syntax with very explicit scoping boundaries. And that, I think, with that, let's go ahead and turn it over to. Is there any questions? Any questions?
Yep, I don't see any. I don't see any on YouTube either.
Hi, Cameron.
Hi.
Uh,
Oh, Boris, goodness gracious, I haven't seen you in a while. How are you doing?
good. Yeah, I was hoping to see you in person, but I guess the weather got in the way.
Yes. Well,
I'm just going to interject here for a second. Cameron, can you stop sharing unless
Yes.
you need to in order to answer a question? Thanks.
I shall stop sharing immediately.
Yeah, so the question I had is actually like the title was regarding serverless computing. So I guess what makes Ecstasy so good for serverless computing or something?
Yes. So it's because the design allows us to actually have stateful applications. And I didn't get to show any of this stuff. I don't have a good demo yet for this. We have some examples, but you can actually have an application that maintains database state that's just as fast to be loaded in and out of memory as if you're just doing a stateless service. And so the benefit of that is that when you deploy an application into a stateless environment, you can deploy the database inside of the application as so basically put a database module inside the application module, and then as it's deployed, the database gets created automatically for the application. So you have a full stateful system that's running in a completely portable, dynamic, autonomically managed environment. And that's where the real value comes in. So yeah, the examples I was going through today, they're cute, they're showing off features and stuff, but the serverless aspect isn't about a feature. It's about when you build an application, very few applications get to be built without having to manage their own state and having to have that state immediately. And so, Boris, I know you have experience with Coherence from when, from years ago when we were working with you. And, one of the reasons why Coherence was so, valuable to companies, building applications around it is because they would scale out the application logic across any number of servers. And every single one of those servers had to have, immediacy of data, right? Every operation that hit one of those servers had to grab 50,000 pieces of data really fast to put together a web page in 2 milliseconds and send it out, right? It's like a race to grab all the data you need, put it together and send out a response. And the applications I'm talking about today are a lot smaller than, banking, order data management systems, and I'm not talking about a stock market here. Like this, I've scaled down the apps I'm talking about for the time being. We're talking about applications managing calendar information, contacts, and sales, and they are operational data systems, but they're for applications that you want to be able to crunch into a data center. You want to be able to take your footprint down in terms of, yes, you have big applications that need 100 servers, but wouldn't it be nice to be able to take 1,000 applications and set those on 2 servers total? Like, so that it's a different class of application, but every one of those applications, when it's getting hit by a request, it has that same need for the immediacy of information that it needs to process the request and put together the response that the user is looking for. And so the serverless environment often takes away that statefulness, right? It says, oh, if you need state, you need to connect to a service, or you need to, there's a whole bunch of things that have to be done to achieve that. And in this case, we're like, no, it's just inside the application. When the application gets the request, the application already contains all of the data it needs to respond to that request. So, Boris, I hope that answers your question.
Yeah, thanks. So it's basically application density and ability to encapsulate that state. Okay, thanks.
Yes. Yep, exactly. Okay.
I don't see any other questions in the chat. Anybody want to chime in real time?
It's because I put everyone to sleep. I got to tell you, it's really challenging presenting, because the only thing I see the whole time is a little camera sits staring at me on my desk and my screen. It's like, so I'm definitely, in my head, I'm trying to imagine, being there with you and actually getting to, talk face to face. But wow, it's I'd much rather do this face to face than over
Oh, absolutely. I'd prefer the in-person events too, and I'm just glad we were able to do this instead of trying to postpone, because that would have been more scrambling and trying to make sure the room is available for that kind of stuff. But yeah, I just wanted to say I had a little PTSD moment when you did that ampersand in front of that variable, and you made that plus reference. Yeah, it reminded me of 30 years ago. I was up to 3 a.m. I kept getting core dumps because I forgot the stupid ampersand and passing a value by address instead of by value.
So I got to tell you, every time I type it, I have that same feeling like, oh my God, it's C again. But there's no pointers, right? It's what it is that you have a name and it represents more than one thing, right? So the name, it's a variable named N, right? And it represents both the value that's inside the N, but it also represents the thing that holds that value. So the ampersand just lets us say, okay, 99.999% of the time, when you say N, you mean the value that's inside that. But every once in a blue moon, you actually mean the object that holds the object, right?
And back in the C++, so I think it was the address of or something, right?
Yes.
And then
the address of.
Yeah, so the method to which I was passing that variable took the reference, but that was interesting. But thank you very much. Wish we can all sit, applaud you in person here for an awesome presentation on this new language and some of the new features. I like that that operator you had, the like the Pascal assignment with the colon.
Yes.
Yes. So that took me back in memory lane too. But
so Pascal was the first language that I officially learned. I was a assembly machine code assembly basic coder on the combination of 6502 and Z80 back in my younger days. And then but I was the world's worst hacker ever, like the absolute worst coder in existence. Like I couldn't read my own code, so if I wrote anything, I had to stay up until it worked, because if I went to sleep and woke up the next day, I couldn't read my own code. I was that bad. And I had a teacher in high school who taught Pascal, and she taught us structured programming, and Stisher was her name, and she was just amazing. So it goes to show you how much influence teachers have.
Oh, absolutely.
And what's the deal with the Darwin Award?
Oh, yeah, I'm always this close to killing myself doing something stupid. Yeah, so.
Well, my wife is a teacher and actually even for special ed, special ed science. So that is, that is definitely a calling, and I know something I wouldn't be able to do. So
yeah,
pretty
no,
cool what he does.
it's awesome, and software in general, the tech industry in general has opened up so many doors for, I'd be a lawyer or something stupid if I didn't code, right? So it's like the fact that computers, opened up all these new possibilities of actual creative, useful things that we can build that help people, and it's pretty amazing. So
Absolutely, yeah.
It's been great to get to see all these things unfold over the years. So it's been a lot of fun.
Yeah, even just seeing how the Java language evolved over the past 25 plus years now. So it's
amazing. It's been very good for the industry.
Oh yeah, absolutely. And for those who say Java is dead, they're definitely wrong. So, but yeah, I've been displaying the QR code for the IntelliJ giveaway. We will do the random drawing after the meeting, probably tomorrow, and we'll notify the winner. So if you can fill that out. So I want to finish up the slide. So there we go. All right. Upcoming events. Well, the big one is the Trenton Computer Festival and the TCF IT Professional Conference this Friday and Saturday. If you go to this here, which I can actually do quickly here, TCF Professional Conference. Yeah, this is basically the target audience is mainly for developers who work for an IT company, and the company will most likely send that person to this. It is a full day of talks. And you can see the speaker grid here, get an idea, you can look at this on your own, but the tracks are app development, computer security, and AI and deep learning. We have a keynote address by Rebecca Mercury, who interestingly was involved in the 2000 elections after, with the fact that the Electoral College was close and the votings, and Florida with the hanging chads and all that good stuff. Those of you who are old enough to remember. This does include a continental breakfast and a lunch. So if you go here, there is information on how you can purchase your tickets. So and also the tickets for students are only $40. All right. So I last 2 months I've encouraged the students at Drew to see if they would be interested in coming down to College of New Jersey for one day. So going back to here. All right. And then of course the price of admission for Friday gets you into the door for the normal TCF or Trenton Computer Festival on Saturday. So it's still, things have been a little bit slow on this Java day. I took out the date, which we tentatively had for this Friday, would have been a separate track, but I need to get back on seeing how if we can schedule that. This is by Oracle, and we'd be getting Oracle speakers either remotely or in person, and so on various topics. All right, so here's what's coming up for us. We're trying to figure out April. We have Timothy Spann, developer advocate. He just changed jobs. He used to be with Stream Native, but he's talking this Friday. So he was, we asked him to present in May. We're trying to get Rustam Mamandarov for June in conjunction with the New York Java group at the QCon event. That's something that's in the works at the moment. And that's in like the 13th to the 15th of June. Matt Rabel, I think, is practically set for October. For September, I still haven't asked him yet. He's him and his wife are new parents. They just welcomed their daughter in 2 months ago. So, but we also have an offer from Bellsoft to present in possibly September. So we're going to work that out, and I think that's it at the moment. Is it somebody has Neil Ford coming up? I'll show you in the slides. It'd be great to have him too come, and Mark Heckler, who was supposed to come in January. they didn't work out for him to come in person. So we're working with him and the New York folks to have him back to back, And Cameron, I know at some point, I know you offered to come back in person. Maybe we can do the same thing. Go to, if your schedule allows, to speak with us one night in New York the next, or something like that.
Sounds great. Sounds
So,
great.
all right. So the Philly folks tomorrow night have a talk on Apache Pulsar with Tim Spann. So it's he's shows up here a lot in these slides. And on Thursday, the Chicago folks have Java on ARM with Dmitry Choiko. And that's at 8 o'clock Eastern time, but they're in Chicago, so 7 o'clock for them. The Atlanta folks, Neil Ford, that's them that have Neil Ford Architectural Foundations. And then the New York Java SIG will have Dennis Magda and Frank Greco, who, as you know, is started the New York Java SIG back in 1995. So, and there's a talk about Chat GPT. So, and there's the QR code one last time. And okay, those are the ground rules. Basically 6 months is the sort of our limit for winning another prize. So, and as I always like to finish up, it's that time of night and to celebrate a great meeting that we've had today with a good craft beer. So, just to keep a lookout for for our website for information on April. The second Tuesday, I think we always try to do, and but we always try to we can adjust based on speaker availability. So just keep looking at that and my emails and Meetup and everything else, and we go from there. So with that, if there's nothing else, first of all, Cameron, thanks. And sorry the weather didn't work out for us.
Yeah, thanks for having me, and thanks for putting up with a Zoom meeting. I know it's not high on everyone's list for best things to do, but thank you very much.
All right, thank you. Awesome. So with that, I wish everybody a great night and a great rest of the week. So.